So as I've been solving, in this video also I've solved 3 different varieties of numericals, MCQs obviously. Now out of these 3 MCQs, I also want to bring to your notice that it's very much essential for us to choose MCQs. Like some of the MCQs would require lots of time for calculation and all. Alright, so please pick up those numericals little later on. Like here, the second numerical that you would be seeing would have lengthy calculations. So though it is easy, but the calculations are very lengthy and you would be getting absorbed into that easy numerical and will be put in lots of your time. Okay, so please beware about such type of numericals where appears easy but then lots of calculation required, which absorbs you into it, kills your time and lose many of those easy numericals which you would have done this way. Okay, so I just want to bring to your notice the second numerical. Please check it out. All right, that's the last attempt. All right, if you feel that, oh, this would have calculations, so last attempt. Okay, so that's one thing which I wanted to make you aware of. And happy viewing. I've been trying to give you all the basics while solving those numericals, and I hope it's helpful for you all. So please see those numericals, absorb those basics and apply for whatever type of numericals you get in. Okay, let's understand this numerical. A particle of mass m is moving in circular path of constant radius r such that centripetal acceleration is varying from time t as k square rt square, where k is constant. The power delivered to particle by force acting on it is. So these are the options. How do we do? Okay, to get into it, there are a few things that you should be aware of. Now first of all, it's a circle which is moving this way. Now I have made it clockwise with radius r. Now what has been provided is centripetal acceleration, which is k square r t square as per the numerical. Now we also know FCP is equal to mv square. FCP is centripetal force, is equal to mv square over r, which is equal to ma. mm cancels, as a result of which we also get ACP is equal to v square over r. Okay, and we should also know formula for power. Power is work over time, which is equal to force into displacement upon time. Now we know force displacement over time is velocity. F into V also becomes the formula for power. Okay. Another thing that you should know is differentiation. That is, if I differentiate dv by dt, that is what is acceleration. Alright, so knowing ACP, acceleration centripetal, data k square r t square, then we derive FCP is equal to mv square over r is equal to ma. Mm cancels, so we derive ACP is equal to v square over r, and formula for power we derive F into v, and dv by dt is equal to acceleration. Now all these stuffs we are going to mix up and get to the solution. Alright, to begin with, this and this both are ACP. Alright, so I can write it as v square over r is equal to k square r t square. So v square is equal to k square r square t square. Okay, what next? Next is square rooting both the sides. We get formula for v, which is k r t. Alright, t obviously you know is time provided, r is also radius provided, and k is also in the data. Okay, now what do we do? Now we go in for this thing. We differentiate dv by dt to get acceleration, and that would be equal to, now we know k and r are constants, so it comes out of differentiation, and we do d by dt of t. Obviously this goes off, so we get it as kr. So dv by dt, that is acceleration, is equal to kr. Alright, now let's get back to our basic formula of force. Force is equal to mass into acceleration. Alright, mass remains mass. Acceleration just now derived is equal to kr. Alright, so we got this formula for our force. Now let's get into power. P already derived is F into V. F is equal to mkr and V is equal to kRT. So what does it come to? So it comes to m k square r square t. So our answer is B. So once again we hit into B. So our answer is B, m k square r square t. Let's try and understand this electron photon numerical. Photoelectric threshold wavelength of silver is 3250 into 10 raised to minus 10 meters. Velocity of electron ejected from silver surface by UV light of wavelength 2536 into 10 raised to minus 10 meter is options, and we have got some data given. Planck's constant H is equal to 4.14 into 10 raised to minus 15 eV. C is equal to 3 into 10 raised to 8 meters per second. Before we get into this numerical, we have got to just brush up our photon electron theory of photo emission. Now this is the monochromatic source of light which is emitted and thrown on an emitter plate. Now the frequency nu has to be greater than nu 0, and if it is greater than nu 0, the threshold frequency, then electrons from here are emitted and moves to collector plate with kinetic energy half mv square. So h nu which was applied, h nu which was the energy h nu which was provided by monochromatic source was utilized for stripping electron, and the energy required for stripping electron was h nu 0 being threshold frequency of emitter plate, and whatever energy left was utilized for kinetic energy. Alright, so let's set up the equation, just recollect the equation that we had done. So it would be h nu is equal to h nu 0 plus half m v square, where v is the velocity, m is mass, threshold frequency, frequency of source, h being Planck's constant. Alright, okay. Now suppose if we want to set up the equation in terms of kinetic energy. Alright, so for kinetic energy it would be Ke is equal to half m v square. Just imagine it stays there, this goes there, so it would be h nu minus h nu 0. This would be our equation. Alright, now if we write in terms of wavelength, because we have been provided wavelength, so let's take this equation in format of wavelength. So this would be equal to also hc over lambda, and let us call this as hc over lambda 0. Alright, so this is our equation. So we have been provided with lambda 0, which is 3250 into 10 raised to minus 10, and lambda is equal to 2536 into 10 raised to minus 10 meters. Alright, so all provided here. Always you have to keep in mind that energy is inversely proportional to wavelength. And why is that so? Because we know E is equal to h nu, which is equal to hc over lambda. Now since H and C are constants, so energy is inversely proportional to wavelength. So lower the wavelength, higher the energy. Now check out over here. Now this wavelength is much lower than this. So obviously when we go back here, the energy H nu would be very high and it would be crossing that wavelength, would be crossing the threshold wavelength. So this would be providing energy enough to strip off electron from emitter plate and for the electron also to have some kinetic energy. Alright, so that's what is it. Now let's proceed. So now if I bring this down over here, it would be HC is common. HC is common, so it would be 1 over lambda minus 1 over lambda 0. Okay, and this would be equal to what? Half mv square. Half, I would put it as electron, mass of electron, v square. Alright, so what are we interested in? We are interested in velocity of electron. We are interested in velocity of electrons. So 2 would go there and would, so this would become 2hc over me, and in bracket would be 1 over lambda minus 1 over lambda 0. Okay, now this is what it was v square. So v would be obviously a root of this entire stuff. Alright, so it is 2hc over mass of electron, 1 over lambda minus 1 over lambda 0. Now we just have got to substitute the values. 2 is 2 as given. Value of H is given over here, 4.14 into 10 raised to minus 15. 4.14 into 10 raised to minus 15. Then C is 3 into 10 raised to 8. Alright. Then mass of electron is 9.1 into 10 raised to minus 31. And here if we take LCM, what would happen is lambda 0 minus lambda over lambda into lambda 0. Let's try and understand this numerical. The momentum of photon of energy 1 MeV in kg meter per second will be. These are the options. Now prior to getting into this numerical, we are supposed to know that one energy of photon would be equal to hc over lambda, where h is Planck's constant, c is velocity of light, and lambda is the wavelength. And now let's get into de Broglie's wavelength. This is the second thing that you are supposed to be aware of. E energy is equal to mc square, which is also is equal to hc over lambda. One c goes away, so lambda becomes, if I take lambda there, now one c gets cancelled, this c, E is equal to mc square, which is also equal to hc over lambda. Now here what happens is this c cancels off and this 2 cancels off. So you have mc left over here and lambda over here. This lambda switches over there, mc comes down here. So lambda is equal to h over mc. Now mass into velocity we know is momentum. So this is momentum of photon and h. Now this we also call as dual nature, where it has got, this shows wave nature, this shows particle nature. Alright, so wave and particle nature. So de Broglie's equation, this is de Broglie's equation for wavelength. Lambda is equal to h over p from here. Alright, so where p is momentum of photon. Okay, so first thing, second thing, and the third thing you are supposed to know is the conversion factor. 1 mega we know is 10 raised to 6 electron volts. That also we know is 1.6 into 10 raised to minus 19 joules. 1 electron volt is 1.6 into 10 raised to minus 19 joules. Now energy is equal to hc over lambda. Now hc remains as it is, hc, whereas in case of lambda we put in de Broglie's wavelength, that is h over p, which becomes, now p goes up, so it becomes hcp over h. So in this case what happens is h and h gets cancelled, so what we are ending up with is cp. So energy is equal to Cp. That's what we have got. But what we are interested in is momentum. So momentum is P. So therefore P would be equal to energy over C. Now energy also if I jot it down over here, energy also we have found out comes to 10 raised to 6 into 1.6 into 10 raised to minus 19 joules. Okay, now let's break up joules. So joules is kg meter square upon second square is joules. All right, and this is then divided by C, that is 3 into 10 raised to 8, and the unit of this is meters per second. So meter stays down and second goes up. Now what happens is this gets cancelled, 1m and this gets cancelled, and we end up with C. Now okay, let's also tackle this. So this, if you do with this, it forms 0.533, so on recurring. All right, 3 5s are 15 and 0.333 recurring. All right, so this comes to, if I take it in terms of 5, so it would be 5, approximately it would be equal to 5 into 10 raised to 5, it would be 5 into 10 raised to minus 22 kg meter per second. All right, so this is what it is. So minus 22, why? Because see, this goes up, forms minus 27. After forming minus 27, this plus 6, so it becomes minus 21, and this we have shifted over here, so that decimal also is added over here. So because 0.5, if I want to write 5, then it would be 5 divided by 10, so that 10 climbs up over here, so it becomes 10 raised to minus 22. 5 into 10 raised to minus 22 kg meter per second is our answer. So the answer is, let's check out what is the answer. Okay, it is it's not there. Okay, the answer was not there. I forgot to mention minus over here while writing, so typographic error. So minus 22. So the answer is D for a change. I hope this video was again quite informative for you all. Please study well, practice well, and take care.